Okay, moving on to the sum of a geometric series. So it's all the terms added together. The results here, so it's a lots of 1 minus r to the power n all over 1 minus r. Like with the arithmetic series, this proof is examinable, and it's not dissimilar, to be fair. So the sum is equal to the first term plus the second term, which is AR times by R, plus AR squared plus AR to the n minus 2 plus the nth term, which if you remember from last week is AR to the n minus 1. So the nth term of a geometric sequence is AR to the power of n minus 1, just as a quick recap. And then you times through by R. So times through by R, get AR plus AR squared plus AR cubed plus AR to the n minus 1 plus AR to the power n. So if I call that one equation 1 and that one equation 2, and then if we do equation 1 minus equation 2, then a lot of these terms are just going to cancel out. So I'm doing 1 minus 2. So the left-hand side, the sum of the first n times minus r, lots of that sum. That's my left-hand side. The right-hand side, this one here is going to cancel with this one here. This one with this one, this one, this one, this one, this one, this one. And it leaves you with just the first term here and the last term here. So A minus AR to the n. You could do 2 minus 1, you'll just end up with all your signs found the other way. And then if I take out the sum on the left-hand side as a factor, and the first term as a factor on the right-hand side, and then divide. But this is examinable, and like the arithmetic one, you need to just be able to run through it and write it down. You won't be asked any awkward questions about it, which might be better, but you won't. Right, so that's that. And I'll go over a couple of examples using that sum. So nice and straightforward. Just find the sum of the first 12 terms. So A equals 2, times it by minus 3 to get to the next term. So R is equal to minus 3. N is equal to 12. So the sum of the first 12 terms is the first term, and then it's 1 minus R is minus 3, N is 12. Just make sure you bracket that negative so you don't get a sign error. And then 1 minus 3. And if R is fractional, obviously you can put a bracketed fraction into your calculator top and bottom as well. And I would actually just carefully put that into a calculator at that point. And that gives you negative 265,720. So this one's going to fluctuate between negative and positive a bit as you go along, because we're timesing by minus 3. So that's literally just applying it into the sum formulae. And the next one is going to have a little bit of logarithms on it. So find the least value of n such that 4 plus 12 plus 36 plus exceeds 1,000,000. So this is a bit like what we did for the terms, but using the sum formula instead. So we want the sum, and it's easiest actually to let the sum equal 1,000,000. You could use inequalities in here, So you could put an inequality in there and work with inequalities if you want to, which in some ways is a little bit more mathematical. So it's A, which is 4, lots of 1 minus, I'm timesing by 3, again, sorry about that, 1 minus 3 to the power n over 1 minus 3, and I need that to equal 1,000,000. So sorting that out a little bit, I've done 2 steps and 1 on my thing. So 4 divided by minus 2 is minus 2. And then we can divide both sides by that negative 2. If you were using inequality signs, you'd have to flip your sign here because you're dividing by negatives. That's why I've just sort of kept it as an equals, because it just takes away having to worry about that. So minus 500,000. And so if I now add to this side, then 3 to the n is equal to 500,001. And then I need to bring down that power. So hang on a sec. You can either take logs of both sides or rewrite this as a logarithm, which is a little bit quicker. So n is equal to log to the base 3 of 500,001, which gives you 11.9. Obviously n is a positive integer because it's the number of terms. So the smallest value of n, where the sum will exceed 1,000,000, will be 12. And the biggest value of n, so that it's less than 1,000,000, would be 11. So you just need to decide which way you need to go with those.